So in this video, we are going to learn about systems of equations. We actually did this back in Unit 2, but we're going to take it more in depth since we have learned more than lines when we did it before. So your objectives is that you can identify the systems of equations and you can state what a solution is to a system of equations. So this video really is just going to be a general overview of what a system of equation is and have you become familiar with it again. So let's review. This year we have learned about 3 different functions. So listed below, we have linear, exponential, and quadratic. So the way we tell something is linear, it has a degree 1 polynomial or has just a single x in it. So example would be like y equals x. Or you may see something like y equals 3/4 x minus 5. Those are all linear. Well, linear has that root word line, so it is a line, and lines can go up, lines can go downwards, and we also have vertical lines, or we have horizontal lines. Alright. Then we learned about exponential in the next unit, and exponential has an x in the exponent. So you might see something like y equals 2 to the x. Or you could have something else in front, like 5 times 1/3 to the x. And if you recall, for the exponential graph, it has that asymptote across where it never crosses and curves up, or it may go the other direction. So it might look something like this. Lastly, which we spend most of this semester on, is quadratics. And now quadratics have degree of 2, where linear is degree of 1, which has the x squared. So they may look, so it's y equals x squared. That is our parent function. But you may have something like y equals 2x squared plus 6x minus 5. Something that's a trinomial. And you've learned that it is a parabola, and parabolas open up, or we may have parabolas open down. So these are our 3 functions that you've learned about: linear, exponential, and quadratic. So a system equation is 2 or more equations. So you may have something like y equals 5x minus 2. And then you may also have another equation like y equals 3x squared plus 6. Well, in this system, we have a line. So we may have a line. And then this is quadratic, so then we may have a parabola. So we have a line and a parabola. And what we're trying to find with the system of equations is where the 2 intersect at. Okay. Well, since these 2 intersect twice, it has 2 solutions. So the solutions is the intersection points. Now it could be 1, or it could be 2, sometimes it could even be 3, and sometimes it can be 0. But we're just trying to find where the 2 graphs intersect. When are they going to be the same? So there are different types of solutions that you could have with the systems of equations. We can have just one solution. So let me pull some examples. If you just have 2 linear, not gonna let me. Let's do. Sorry, it's being tricky. We can have a linear and an exponential. They only have one solution. Or we could have maybe just 2 quadratics. There, and then maybe this quadratic, like there. They only both intersect one time. Actually, I'm going to take back the first one, because this one actually is going to intersect twice. Alright, so a better example for the first one, let me draw a couple other lines. So you might have a line like that, and you may have a line like that. Alright. So when we have no solution, which means they do not intersect, so that could be a situation like the following. Alright, so I could have maybe a quadratic, like so, and then I'm going to have another quadratic, now right now you can tell that they're going to intersect, but if I take that quadratic, if I can get a hold of it, and then I'm going to rotate it so it opens down. So those two quadratics would not intersect. Another case where they may have no solution, they can bring in our exponential, like so. And then maybe we can draw a line. Make it a different color. Those two would not intersect, so there is no solution. Alright, so sometimes we can have two solutions where it's going to intersect twice. So in that case, let's copy our exponential. Like here. And then we can draw, I'm going to do the one I tried to do before, but I messed up on. A linear. And the linear intersects it twice, so we have two solutions. Or we can have two parabolas. So let's draw another parabola, like so. And then we can draw another one. And those intersect twice. We have two intersection points. Or we can have many solutions. Now this one's only going to happen when you have two of the same function, like linear. So in that situation, if I have a line, right so, a many solution would be the exact same line, so they're on top of each other. Or I may have a parabola, like so, and then I may have another parabola just like it. Just make it a little bigger. So then they are many solutions. They touch many, many times. You can't even count. So that's it for the video. So review, a system equation is two or more equations, and the solutions are the points or point of intersection, which in that case, remember, you can have 0, you can have 1, 2. There are some cases when you can have 3, which we'll talk about in class, or we may have many or infinite solutions. Reminder to do your reflection so you can get your bonus points.